Hey all beautiful people out there, what's up? This is Avhijit aka the Code Man. Welcome to the second part of Introduction to the Generics tutorial. And in this tutorial, we're gonna be seeing why we need generics in Java. What is the use of generics in Java? So last time we had this code typed out here, and we saw the usage of collection framework in Java. Now in the last video, I gave you an intuition as to why we need generics in Java. The reason is that if you happen to add an integer object, an integer value into the list created here, for example 1, here, you're gonna get an error, which is going to be a runtime error. As you can see, the string values have been printed out onto the console, but there has been a java.lang.classCast exception, and this exception is occurring because of this part of the code. This part of the code where the programmer has to explicitly convert the object data type back to the string data type, downcast it back to the string data type. So at this point, what you're doing is that you're downcasting an integer to a string, which is incompatible, and that is why this exception has been thrown. So Java programmers around the world decided to come up with a method to avoid this runtime error, and that's how generics came into use. Now, generics means that in Java, generics means that we are gonna give the compiler explicitly the type information so that the compiler can perform all the type safe operations at the compile time itself and avoid producing runtime exceptions. So how do we do that? We do that by specifying the type information inside angular brackets. Like here, if we want the integer, the list data type to take only the string values, then we will be specifying it explicitly here using generics. So here list string L equals a new array list, and here also it's gonna be string. After you do that, in order to iterate over the objects, you also need to pass the type information to the iterator object. So here also you will type out this string. And now, since the compiler already knows what the type of the data stored in list would be, so the programmer don't have to explicitly downcast the object data type back to the string data type. This will be done by the compiler itself, so you don't have to type it out there. And let's compile. Okay, yeah, actually we need to comment this out. See, you get the output and it's of string data type, and here the compiler implicitly downcasted the object data type to the string data type. Now if I uncomment this part of this line of code and run the code all over again, then the error that you get is compile time error, and this has been thrown because the compiler has already performed all the type safe operations, and it has come to know that the list which should be of the string data type contains one non-string data type, and therefore it shows the error in the compile time itself. And suppose you want the list to be integer data type, then let me comment these lines of code out. Then you need to specify here integer, and when you specify the integer data type, remember that collections interface cannot accept the primitive data types like int. Uh, Primitive data types are these data types where you specify the keywords int, double, float, like this. Instead of using these primitive data types, you have to use a wrapper class where you have to wrap these primitive data types into a class that can be accepted by the collection interface. So for int or the integer, we type out the whole integer. We use this keyword. This is the wrapper class for the int data type. And here too. And now here also you need to store int a equals to iter dot next. Let's add one more, l dot add 2. And execute it, and you get 1 2. Now I would like to explain this line of code more deeply. Oops, sorry. This whole line of code. Now the value that you have passed here, the type information that you have passed, is not primitive data type, but the value that you're storing here is of a primitive data type. So what happens here in the background is that from JDK, post JDK 1.5 Java, there's a feature called auto. Let me comment it out. Auto boxing and auto unboxing. Now what happens here is that you have passed the integer wrapper class into the list. So the first thing that happens at this line of code that the compiler does implicitly is that first it downcasts the object data type to the wrapper class data type of integer, that is integer data type. And the second step that's been performed here is that this integer data type is unwrapped to give the primitive data type. Integer data type is unwrapped to give int data type, and this is referred to as auto unboxing, and this value is stored inside the primitive data type variable a. So these things are done implicitly by the compiler, and it's been possible because of the introduction of generics. So, and also one more new concept that has been put up in a post JDK 1.5 is enhanced for loops. So the syntax for enhanced for loops is as follows. So for enhanced for loops, you don't need the iterator interface and iterator object. You can just type out for. Now, so it's int I in the list system.out.println I. Let me comment this whole part so that you can. If I execute this, you're gonna get the same result. So what happens is that there's an integer I uh, object here which iterates through every element in the list and prints it out. Here also these two steps are performed by the compiler implicitly. So that's it for the introduction to generics. Now we're gonna dive deeper into the concept of wildcards in Java, the different type of wildcards in Java. There's the lower bounded and the upper bounded wildcards, and why they are used in generics, and what is the use, what is the importance of usage of generics and wildcards in Java. So that I'm gonna cover in the third part of this tutorial. So stay tuned, and if you like this video, give it a thumbs up and also hit the subscribe button so that I'm motivated more to make such videos. And that's it. Peace.